And we have a fantastic team of panel experts. Dr. Dou Zhang from China Telecom Research Institute over here. And Dr. Wang Ning from China Mobile Research Institute. And Dr. Dongxu Zhang from Nokia LL. And also my colleague, Professor Yixiao Zhu from Shanghai Jiaotong University. And this symposium was very generously supported by Sun Telecom. As you can see from the video, Sun Telecom is it's a local company in Shanghai, right? But it's also a very international company. In the past more than 30 years of time, Sun Telecom served customers from more than 130 countries and regions. Right? It's really phenomenal. And Sun Telecom has a very compact but very competitive management and technical staff team. Today we are very happy to have the founding couple of Sun Telecom, Mrs. Liu over here, and Mr. Tsai. Thank you for your generous sponsorship. And next, I would like to invite the CEO of Global Business of Sun Telecom to come and share with us some words.
Thank you, Professor Sun. Good afternoon, distinguished speakers, colleagues, and friends. On behalf of Sun Telecom, a fiber optic total solutions provider, serving over 140 countries and regions, I'm honored to welcome you to this special symposium on state of optical access networks. The evolution of optical access is a driving force behind the global digital transformation. Today's discussions on standards, deployment, and applications are therefore essential as we move forward. We are very privileged to have top experts from China Mobile, China Telecom, Nokia Bell Labs, and Shanghai Jiaotong University to guide this conversation. My sincere thanks to our organizers, Shanghai Jiaotong University, especially Professor Sun, and the China Mobile Research Institute for the excellent collaboration in making this event possible. To all our speakers and participants, thank you for your time and engagement. Let's make this a truly insightful session. I wish you all a productive and inspiring symposium. Thank you.
Very well said. Thank you, team. In the past several months, during the first half of this year, I had the opportunity and also a very great privilege to talk to the customers and also partners of Sun Telecom. And in the conversations, we realized that our partners, especially from the global south, they are really great need of the devices and systems and equipment that we made in China. Everyone agree with that. And also we realized that probably more so, our partners need the insights, the knowledge, the experience that we accumulate in the process of rolling out probably the world's most advanced, the most high-speed, most massive network infrastructure. Right? These experience, this knowledge is going to help them to make wiser decisions when they would like to roll out a new network or upgrade their existing infrastructures. So this is why we're here, right? And so we have a pretty good room for people in this room. We also have an online broadcast, and we have online participations as well. So our time today is going to be divided into two sections. In the first section, I'm going to invite everyone, experts, to present an invited speech, about 20 minutes. And at the end of a speech, I invite every one of you to raise your questions, to ask the experts difficult questions. And then we're going to have a panel discussion. And during that phase, we also welcome questions. You can write down questions on the paper and then send questions to our volunteers. Then we will be able to answer and address those questions during the discussion phase. Okay, everyone, get engaged. Okay, without much ado, I would like to start our first section. Let's invite our first speaker, those China Telecom. I assume many of you already realized Deng Zhu was recently elected the chair of ACP. It's really a great achievement. He probably is one of the best person to address us on the access network technologies. So please, President.
So, first, I would like to thank Professor Sun for the warm welcome and invited, and also thank the Sun Telecom to have this opportunity. We can join here and discuss the recent progress of the FTTX technologies. And generally, I think I would like to share, the FTTX. What's the situation of the FTTX in worldwide? Here is the data from the ITOT. I think this is a very official data. Everyone can find it in the ITOT, the website. And generally, we find that the broadband services are advancing with data traffic explosion, very huge. Generally per year, 9%. So that is I believe that is the core rate and probably the first priority reason behind, the broadband access market, the global market. And well, if you look at the total FTTX deployments, you will see that the current have been increased. The worldwide from the 36% probably to this year very close to the 60%. So generally, I believe the FTTX market is still in a very dramatically increasing speed recently. And beyond that, the gigabit and the multiple, thank you. Beyond that, the gigabit and the multiple gigabit broadband subscription also increased. We estimated that given the OBDIA data, generally it will be increased to the 44% probably at the end of the 2028. So that is also, the market is there and the customer is there. So generally we have everyone here, we have the opportunity to do the research, to do the marketing, to do the product, I think. If you look at the data in China, I think this is a very deep impression. Example first, generally in the total, the whole number in China, we have about 695 million customers, FTTH customers. So this is I guess this is probably the biggest numbers for countries in the world. And if you look at that is the customer side. But if you look at in the sales side, generally with sale purchase, we have built around 12 billion FTTH ports. That means the ports can be sold for each customer, and for the 10 gig PON ports capable of providing the gigabit access, scalable gigabit access. Currently, we do have more than 30 millions of that. So that is the baseline. That is the fundamental infrastructure to guarantee scalable gigabit access to each customer. And in the sales side and between the customer and the sales side, the fiber infrastructure also important. Totally in China, we do have the 74.44 million kilometers of fiber optical cable, and 60% of them are in the access part in the optical access systems. So generally, this is also very huge in the resources. Also, the fundamental guarantee the access capabilities for our customers. Regarding the recent progress, I think the hot topic is the 50 gig PON. This is a technology started in the FSON and ITOT and standardized in the ITOT standard group 15 question 2, and also to provide the scalable 10 gig access capabilities. I think this one, 50 gig PON, the first time I introduced the 50 gig PON in domestic China, maybe it's probably 6 or 7 years ago. I think. And now I have to say that 50 gig, which can enabling 10 gig access scalable. The core reason behind that is very well defined technical standards or recommendations in IoT. We have the 9804 sets and also the 9805 coexistence to make very good, the ecosystems behind that. So if you look at, if you go to the CIOE last year or probably this year, you will find a lot of the, system vendors, the chipset vendors, and also the optical component vendors, the electrical power vendors. A lot of vendors, they are working on the 50 gig PON technologies and offer very excellent products to make it successful. So that's we have seen very mature industry capabilities to support to make it happen. So that is also important. But generally, we think that the 50 gig PON was a big difference for our customers. Well, probably in the previous, as I have shown the data for the 10 gig PON, that's for the scale with gigabit access. But for the 50 gig PON, we can offer scaled 10 gig access for everyone. So that's important, I believe, for everyone customer. So yes, I'm an operator, but also I'm a customer, I think, right? So 10 gig access can help us with the better services, with the higher residential videos, and in the factories, we can enable very advanced AI technologies. So that's very important, I think, for the future. Generally, because this is Symposium, I would love to discuss the detailed technologies here. But what I would like to tell you is that generally the maturity, the 50 gig industry is quite mature. So there is, a lot of them work on it very hard, I have to say. And we have solved many technical issues in the past 4 to 5 years. And if you look at the news, published news, you will see, well, probably 3 coexistence have been worked through, and we have some prototypes for that. Right? We'll have sometimes for the symmetric, we'll have the C+ OPL achieved. But currently, by far, for the volume deployment of the 50 gig PON, we have to say only, probably 1 or 2 issues left to solve. The first one is, small form factors of the 3Gen 50 gig PON optical module. That's 4. Because this is the core technology. This is not a pure technical issues. This is, the mixed, the technical and engineering mixed issues. Because we want to package all the, 3 transmitter, 3 receiver, and also probably other, WDM, and also electrical, and also DSP chipset into very small form factors. So not so easy. So that is, but this is very important just because this one can enable the per line card. We have the 16 port line density. So that's quite important for the operator's deployment, because in the past we have the 10 gig PON deployment, we have a similar density there. If we decrease the density, then we will have much more requirement for the the space, the electricity. So that's not so. That means money and complexity. So that is one thing to be solved. Another thing I think is for everyone here is quite important is IOP interoperability. We have done the IOP for the G-PON, for the XG-PON, XGS-PON in the past. So that is why there are so many own use home gateways. A lot of the brands, I think, create a lot of job opportunities for many of them. So interoperability is quite important to also to make 50 gig PON successful. We can make a very good ecosystem for that, and to lower the cost, and to make more and more people can use the 50 gig PON technologies. Well, generally in the past 2 years, we have seen a lot of the provinces, probably by now more than 20. The provinces have released the policies or plans for the scaled the 10 gig optical access capabilities based on 50 gig PON technology. Earlier this year, and also MIT, with all of that, right? MIT launched the 10 gig optical network pilot programs. And by now, in the MIT programs are totally about, 160, I have to say. But even for the China Telecom, we have by now we even have more than 150 gig PON based pilot programs are running. And cover 3 aspects. The first is the residential community. Second is the 10 gig factory, and the third one would be the technical parks. So that is the different aspects, not only for the residential, for the internet access, but also used in the school, in the parks, and in the factory, lot of them. Here, just to show some, various industries use the 50 gig PON. We use it for example, we use it in the steel, product line, and based on very high, backhaul traffic capabilities, then we can enable very high residential AOI technologies to help the factory owners to very efficiently to pick up those materials not so good and to raise the efficiency. That's quite important. That means save money, right? And another thing is that another one probably we can use the 50 gig PON together with the high residential camera. Then originally those works were done by people, right? But now we can do it automatically. Then much more safer. That's quite also makes sense for the industry, I think. So there are a lot of the cases we just use the 50 gig PON to do for the park, for the school, and for the probably also the parks, the schools, and also the residential. But I think probably next speaker or even other speakers will mention that. Well, regarding the future evolution, I think generally there are several topics we can discuss. People may talk about AI, people may talk about high speed. All of them are right, I think. Generally, but now I can report to each of you that just in last month, in October, in ITOT, study group 15, the one technical report has been finalized. I don't know whether now we can get it from the ITOT website. I don't know, but probably it's still in the work in progress. But it has been agreed to include to guide what will be the future, for the characteristics, for the features, for the architectures, what will optical network would be, including the optical transportation system and also including the optical access networks. So if you look at it, probably the optical access network with the fiber in premise, so have the architecture there, very huge, ambition there. And also we will have the AI technologies to build in to enable, the new features to make the network much stronger or much more smarter. So that's another thing. And also we would like to include the sensing to get probably, in the past, we just talking about the communication capabilities in our networks. But now we are considering to integrate the sensing as one of your new features. Then the sensing can be, we'll call it as sensing as a service. I will introduce it later. But generally, it can be used for operation, maintenance for the operators, but also we can offer, based on that, we can offer the services for the smart cities. So that is another point of the sensing as a service. Earlier this year, Telecom network 3.0, but generally, well, if you are interested, you can get this white paper from the internet. It's published, but general idea is that it centers on the overall optical intelligent connectivity and also integrates the optical network intelligence to expand from traditionally the ground-based the optical communication network to the aerial network and build a robust network infrastructure, especially for the AI era. So we have identified the AI era and or AI traffics as the future most important services, we believe, generally. And well, back to the optical access network. So the first focus is still the speed, the high speed. I think the Epson and ITOT work together and have identified 200 gig PON as the next generation PON after the 50 gig. ITOT has finished the first version of the VHSP. We call it VHSP, very high speed PON. Not so good name, right? The very high speed. High speed, we have high speed, we have very high speed. I don't know what's the next. Yeah, probably, yes. Good name. Yeah. But anyway, we got a lucky number, the published supplement 88 in Chinese, right? This is lucky number. But generally, we have worked on this project for 3 to 4 years. And also we have a lot of the technical options have been included, have been analyzed, and have been written down in this specification. I have to say the supplement, not the formal recommendation. And the revision project has also been launched. So the target is to work together with Epson to do multi-round of the analysis and the comparison, probably also the debate and the competition, and try to narrow down the technical options and try to figure out what will be the most appropriate technologies for the future recommendation for the standardization. So that is the next step, I would say. And this one probably we will spend probably 2 to 3 years. So, probably we will know what will be standardized probably in the end of the 2027 or the 2028. Just around that. Regarding the requirements, just as introduced, we have 200 gigapon requirements from the communication to the communication with sensing. I just introduced. So the first one, the 200 gig is not line rate anymore, it's just the system capacity, system service capacity. So this is a new concept. So not similar to the traditional or legacy PON systems. And this is so technical details. I think most of them will know that. Just ignore that. But the new things I have to say is that the sensing is still in the preliminary the phase of the research, and I think also in the past the communication capabilities have helped not only operators, I think the whole industry to make money. Right, this is a good thing, and we also believe that the sensing over the optical access network is the second. So if we can well-defined features, the characteristics, then not only to improve the efficiency of the maintenance inside the operator's company, but also to try to offer probably new services and new opportunities, market opportunities for everyone here, I think. So that's a good candidate. But generally, we have from the technical point of view, we have a lot of the difficulties there. Everyone knows that we have the branches after the splitters, right? How to distinguish them and how to overcome those very high, optical loss, especially in return, right? So quite high return loss. So how to overcome that? There's still on study, I think. Also encourage experts, professors, experts in the industry to join us and to start it. Regarding the communication part, we do have the technical routes, the directed detection, and also with the coherent series. The directed detection or legacy PONs, G-PON, XGS-PON, 10 gig E-PON, 50 gig PON, we are always, DD, we call it IMDD, right? The IMDD is, very familiar. We are very familiar with this. This is when we try to define or discuss what is the next generation PON, the IMDD is always the first words we are thinking about. But now we have another one. It's just because that we do have a lot of the technical difficulties for the IMDD, especially talking about 200 gig PON. If you want to achieve the system capacity, service capacity of 200 gig, then if you over the one wavelength, then you need to, for the IMDD technologies, then you need to have probably the 230 or 250 around that the baud rate. Then not so easy, especially to adapt to satisfy the requirement or the high OPR requirement for the optical access network. So not so easy things to do that. So here is a picture we just discussed last month and also included in the supplement 88. So this here shows the research sensitivities in the industry. So by the end of the September this year, I think. And I think probably the next year this figure can be updated. We will see a lot of progress probably in the future. And this will also deeply influence the future 200 gig PON technology, the comparison and also the standardization progress, I think. Another part I would like to discuss with all of you is that is AI. So everyone talk about AI, right? Everyone mentioned AI here. But what will AI can be used for the optical access network? So this is architecture also included in the white paper Telecom published earlier this year. So the core idea, we just want to use the AI technologies as a one core enabling technology to help us to transform our optical access network from the passive network pipe access, aggregate, and to upload from the passive network pipe to the computation and network intelligence integrated networks infrastructure. So that is our vision, I think. And a lot of things will be done on top of that. Probably from for example, from static pipe to probably to the flexible access. I will introduce the detail later. And one core technologies behind is that a lot of the AI agents will be built in try in the ORT, in the ONU, and also probably in the cloud, and to work together and to coordinate among them. To try to, the multi-agent cross-layer coordination based, we can do the flexible link capabilities and also do the service automations. So you should probably don't have a lot of the, give one example for you. So now, if you want to have a service, the fundamental access capability, if you want to get, you will have to go to the offices, China Telecom's offices, China Unicom's office, or China Mobile office, right? And if you have some additional service, probably you can use the app, right? But for example, if you watch the football games, where I want to have the one, probably only 2 hours high rate access, how can you get that? Can you get other abilities in minutes level? No, you cannot. So that is the target we want to have. Talking about the AI, I will have to say the first, the AI for the optical signaling process, this one, or we can say that is the AI for the PMD level. So this one, I think, is quite important for us to overcome those difficulties or the traditionally very difficult things in the optical access network. So what is the biggest difficulties in the optical access network? OPL, 32 dB or even higher. We believe that the AI technologies will play a very important role. And this is just the works I just pick out, in the past. We have seen, OFC papers, in the GOC papers, GRT papers. We have seen a lot of them, but still we still need more to try to get higher, improvement based on the AI technologies. Here, just some examples here. And the second part, as I just mentioned, the AI technology can help us to improve the OEM efficiency from the static path to the dynamic path, and with flexible SLA guarantee. So that's another thing. And also not only in the service level, but also in the ODM level. So just imagine we have the physical networks built on the ground, right? Or some fibers in the pipe. Can you have a full image in a digital twin, probably in the digital space? And if something happened in your ODM link, can you get that in the digital space within probably 5 minutes? No, you don't have it now. But that is also the target in the future. See? If we can have that abilities, then for the OEM, will be quite easier. Here, I would like to share a very small video here. This is for the flexible access, these capabilities. We want to enable e-commerce driven and also cost-effective and also on-demand flexible high-speed intelligent connectivities for the important services raised by you. Watching football games or the business, if you want to access the remote data center just for the training data, probably 10 gigabit or 100 gigabit, you can get it on time. And then when the transmission finished, you can just disconnect it to the link. The charge will be small, I think. So that's the core idea of this flexible access. Well, for the technical details, a lot of the technical behind, the operation systems of the China Telecom, all operators I think are very complex, right? So what is our target? Is just to overcome those difficulties. I try to build a very flexible and cost-effective on-demand these capabilities for everyone here. This is the first trial of this one, flexible access we have done in some provinces. We have done, in Sichuan, we done for the cloud gaming, and in Jiangsu we have done sample data ingestion, and we also do the RDMA in Shanghai. A lot of trials here. You have seen the effect. The result is quite good, I have to say. And we can establish and also disconnect the link in the minutes level, and we can reduce the latency probably by about 30% around that. So this is quite good. And so this is our target, to provide the better service for everyone here. Okay, so that's all I would like to share with you. Oh, sorry, that's really small. Thank you.
Any questions?
Yeah.
you think that 200G PON will still need to coexist with G in the future?
It just depends when the G-PON will be rolling out. That just depends. And well, the answer will be various, I think. I have to say. We have a lot of the discussion in the lifetime. Generally, if you look at also the supplement 88, you will see a very, very huge coexistence figures there. And some operators think that, okay, now we have the GPON, and we will still have the GPON probably within 10 years. Then we need the GPON coexistence with 200G. So we don't have the answer yet. We don't have a decision yet. So still depends. Well, depends. But you know, answer your question is not so easy generally. I have to say, because too many technical options will dramatically increase, the technical decisions or for the recommendation or standardizations. Why is optical? Why GPON, XGPON, or even GPON 2 for the Verizon are successful? It's just because we focus. We don't make too many technical options. That is why all of us join the work and make this successful. But if we, GPON coexist with 200 GPON, definitely we acknowledge that this is quite reasonable for some operators. But I don't know whether how it will influence the future, the technical, especially wavelength decisions. That's the answers I can give you. Thank you. Very fundamental and core questions.
Two questions.
Yeah, sure.
Very interested in the idea of provisioning dynamic connections to customers.
Yeah.
So what kind of customers are you consuming? Residential, business,
All of them.
All of them.
Yeah.
So,
if you look at the trials we have done here,
yeah.
for the trial we do is the cloud gaming, definitely for the residential business.
Okay.
Yeah.
Okay.
And also for the RDMA or the sample data ingestion business.
You mentioned AI.
Yeah.
AI is being talked about everywhere.
Yeah.
And then about network OEM.
Yeah, that's right.
So I would like to know when you introduce AI into the OEM system,
yeah.
Are there any potential interoperability difficulties? Yeah, when you introduce more and more into the system, will it become more difficult to interoperate between different systems?
Oh, that's a really good question. But generally, let me think about it. But generally, to me, there's different levels of that. As I said, well, let me take this. Take this one as an example here. We do have the AI. Probably in the future, we'll have the one agent to collect the data. We just do some training here in the RT side. Or the data comes from the one or two home gateways OEMs. As I have said, interoperability is very quite important. RT probably from vendor A and home gateway probably from the vendor B. Generally, we need those different AI agents running on the RT side, running on the OEM side, can talk to each other. Yeah. That's the one kind of we do have the A2A protocols in other areas, but what is A2A is also access. We don't have the answer yet. That's really needs future research on that. And another one, interoperability is from the RT and also with the cloud side AI. Especially for big data training, to use the resources built in RT is not so efficient. So, just give one example. Based on the one typical RT chassis per second, we will have 300,000 data we can collect. So that's a huge data you can imagine, right? So the ideal mode is we can train a lot of the data in the cloud. And then we need the cloud can talk to the RT side. That's another kind of the interoperabilities. Yeah, thank you.
Next, I would like to invite Dong Xu from Telecom-Fiber. You can introduce a little bit for your company, the role. Okay. And about yourself, please.
Hey, hello. Good afternoon, everyone. I'm Dongxu from Nokia Bell Labs. Nokia, I think most of you must know that is a leading vendor in optical access, and Bell Labs is the research arm of Nokia. So my talk is mainly focusing on the technical outlook part, for next generation PON, maybe from both technology and applications perspective. Okay, so just little advertisement, but this is Nokia's product just released last month. It's 50 gig PON for enterprise solutions, and you can see the line card in ONT terminal device. And one of the selling point is that it's not only compatible with GPON, NG-25 and 50 GPON, but also designed to be future compatible with 100 gig PON. And actually, there have been quite a few operator customers around the world trialed our 100 gig demos. But this may sound a little bit weird if we were working in the standardization, as Dezhi has just introduced. The industry is having a strong sense that the next generation might go for 200 gig capacity. So there is no such a thing of 100 gig PON now. So this actually reflects one of the Nokia's deep concern about the next generation technology choice. Yes, just as Dezhi has said, there is a debate of IMDD and coherent. So 100 gig PON means that Nokia is now still preferring the IMDD choice. And so why is that? Actually, Nokia is also a very competitive vendor in coherent optics. But inside the company, we have this lesson learned from the history. Yes, in more than 10 years ago, there's the NG-PON2, the WDM-PON solution. At that time, it was Alcatel-Lucent, not merged with Nokia yet. And the company had always been a technology leader in PON field, and also successfully pushed this NG-PON2 standard that I think it technically is indeed a very elegant solution. It is reuse everything from the 10G PON, physical layer and TC layer, and you add up some wavelength channels to enable another layer of flexibility. But 10 years later, of course, we don't like to say it's a failure, but admittedly, it's not as successful as originally expected. And the sole reason for that is its cost is too high compared to the single wavelength IMDD. And so the question is, what if we now we are facing a similar situation now? We are facing if we can choose the coherent optics, we can go for 200 gigabits per second, but it's more expensive. And so what will be the answer of such a question? Will coherent optics be acceptable in the future to cost reduction and applicable in PON? And to answer this question, we can dig in a little bit into the coherent optics. And you can see this is a coherent optical module, and you can immediately identify this major component there. The ITLA is a tunable laser, very narrow line with high performance laser, and then you have a COSA, which is the optical front end. It's in this case it's a silicon photonic one, and also there are other options like indium phosphide, and then you have a DSP chip, and usually there will also be micro EDFA to amplify the output signal, and then of course that is with the pump laser, and in this case it's hidden on the other side of the PCB. So there are of course smaller module form factors, but the structure is roughly the same. And if you break down the cost of each component, you'll find that the tunable laser, the ITLA, take a very significant portion. But please don't take it too seriously about the exact numbers, because that will vary case by case. Like different vendors, of course, have their own cost structure. But generally, it gives you the sense of how much a component will cost roughly. And then, especially in the early phase, the DSP chip will cost a little bit higher proportion, because you can only find like only one provider in the market with the advanced 5 nanometer process. But as the market mature, there will be more DSP providers, and like Nokia, we have our in-house DSP design, so that will shrink gradually, and the RTLA takes a bigger portion of the cost. That is because the ITLA, the tunable laser, is a standalone component. It can't be integrated into the closed-line DSP. It has its own packaging and manufacturing procedure. So that so as the market volume grow, you can expect a pretty sharp DSP cost erosion curve. But the ITLA will be roughly flat. But there is indeed a possibility that in the future that ITLA might be integrated with the COSAP, because as the heterogeneous integration technology advances, there is indeed such a possibility, especially if you consider indium phosphide PIC. This is already happening. Infinera, now part of Nokia, is known for that integrated solutions. But the thing is that the problem is that indium phosphide wafer itself is still very expensive. And as far as I know, indium phosphide don't have large size, like 12-inch wafer size yet. So we don't know when and how the cost of ITLA problem will drop to an acceptable level. And another factor is that how much volume we can expect from the coherent DCI, the data center interconnect market. And from some publicly available data, that the estimation is about 5 million accumulated from now to 2030. And actually, I think that is actually not a very big number, because if you compare it to PON port, the ONU port may easily be 1 or 2 order of magnitude higher than that. And of course, don't forget there will be multiple different types of coherent modules, like silicon and indium phosphide and other new materials. So that will also dilute the cost reduction speed of coherent optics. So back to the original question, whether and how we can be sure the coherent optics might be low price enough. The answer is at this stage we are not sure. And so yeah. And on the technology side, there are of course some possible ways to deal with the cost reduction in the coherent transceiver. And here I have several examples, like the MD and the coherent hybrid solution. I personally think this is very promising, that they will only use the costly coherent optics at the ORT side. And then you can, of course, reduce the cost of ITLA, like this is a paper published by my colleague Ali Hossain, which tries to replace the high-cost narrow line with ITLA with a low-cost DFB. And then you can simplify the front end with very few ADCs. And then you also can, from the system level, introduce frequency division multiplexing, in which case you can only receive a little bit of bandwidth in the ONU side, which helps to reduce the ONU cost. And and this is a list of publications that we recently have published on these related topics. But I'm not going to details, but if you're interested, please refer to those references. And then let's go to the application perspective. And first, I want to share with you this interesting concept that humans and bandwidth limit. Actually, we are entering the over resolution area. If you think about the screen resolutions, we have our phone easily go up to 2K and 4K resolution, but its redundancy is in the experience increase. If you think about the top level visual effect product of the Apple's Vision Pro, it's actually just the 4K screens inside, and it makes not much more sense to further increase to 8K or even more. And actually that is supported by Wi-Fi 6, which is less than 1 gigabit per second. And actually, biologists have already measured how much our brain can communicate with the outside world. And actually, it's very disappointing. Only less than 10 megabits per second. This is easy to measure because our brain has limited number of nerves connected to our eyes and ears. So you count how many nerves there and the biological spiking rate, and you convert that into the digital signal bandwidth. You don't need too much bandwidth to satisfy the human brain's top capacity. So that is the bad news, actually, I think. But it implies that maybe the next generation PON, we can't consume 200 gigabit per second by purely human services. Yes, that must be go for some other like AI and the machine communications. So this is the question that when I started the coherent PON research, we asked ourselves this question: in what application scenarios can PON, especially coherent PON, given it's very expensive to justify its cost? And one of the answers, this example I'm giving here is fronthaul, and more specifically, is self-read MIMO fronthaul. And self-read message MIMO is one of the most important technology evolution direction for 6G and even more beyond communication systems. And it is a combination of massive MIMO and small cells, where you can deploy the antennas in a distributed way, and but process the signal in a more centralized manner. And also, this is a very dynamic system where the users move around the area and the access point dynamically form clusters to serve that user. So this kind of system have very specific fronthaul challenges that are very simple for PON. And first is, of course, bandwidth requirement. And on the bottom right, you can calculate how much bandwidth is required. And for a typical 64 antenna system, it easily consumes several hundred gigabits per second. But that is, of course, the maximum bandwidth. You will expect some statistical multiplexing, and by that case, 200 gig PON might be a very appropriate choice. And then you have the power consumption challenge. In the traditional fronthaul, you have Ethernet switch and really a lot of optical modules, and that add up to a huge amount of power consumption if you have a large number of access points. And then it's naturally to think about replacing that Ethernet network with passive optical network. And more interesting, you can consider joint wireless and optical layer scheduling. Then you can consume energy proportional to the real traffic and actually amplify the bandwidth, amplify the power saving effect benefits. And we take that very seriously and consider how much energy it can save on Earth. So we quantitatively evaluated that problem. And this is a system simulation we have done. Like this is a wireless self-read MIMO system. You can think of these moving dots are the user equipment, and the wireless system dynamically serve those users. And then you schedule the optical fronthaul with frequency division multiplexing flexibility. And the result is that, you can expect more than 50% of energy saving by introducing coherent PON into that scenario. But of course, it needs some joint optimization across the layers. And actually, we have done that. It's not very difficult to achieve because we can use the readily available Open RAN control plane. This is the Open RAN intelligent controller, and we extend that existing interface, write a service model for the PON scheduling, and you can achieve this experiment screenshot that you can have these control messages for both RAM and PON, and you can save a lot of energy. Another interesting challenge that is very unique in this self-read massive MIMO is that you have to achieve very high quality radio frequency synchronization across those different access points. But traditionally, those access points will synchronize to a common clock either from satellite or from the Ethernet link. But the phase-lock loops at each station will introduce inevitably some phase mismatch, and then it will degrade the MIMO signal noise ratio. But if we introduce a PON-based front haul, we can use some simple microwave photonics techniques. We have this high-quality frequency source at the ORT side, and then you broadcast it in the optical layer. So it's perfectly cloned to every radio unit. So the same frequency can serve the UEs without any phase instability. And we actually measured all this. We have built up the test bed to demonstrate all of the challenges and solutions mentioned above. Like here, we have measured data transmission of several 8 subcarriers with 200 gig capacity, and then the microwave photonics radio source modulated at the optical cone. And over the PON transmission, there is a very importantly photonics integrated chip to extract and filter that data channel and frequency source. And then finally, we measured how much benefit it brings to the wireless system. And the result is that MIMO EVM in performances can be greatly improved. Okay, that's just an example of next generation PON application that might make sense. And to conclude, first from the technical point, we think IMDD, yes, still in this stage, we can't overlook the possibility of IMDD as a next generation choice. And the debate around IMDD and coherent will of course continue for some time. Although there are many innovations coming in as a researcher, I like the coherent PON research, but as a vendor, a more responsible promise would be that let's wait and see. And then the application side, maybe non-human terminated service will be the first landing scenario for 200 gig PON. And then self-MIMO might be a good scenario that we can push for the application. And that is all my talk. Thank you.
Excuse me.
Yeah, maybe one question also to your last slide. So do you think that if inter-data center coherence makeup, that somehow it's also solved for the on-site, because then we have much more very low costs coherent components available. Otherwise, it's questionable if
Yeah, exactly. The only hope for I think the only hope for coherent PON will be relying on the data center coherent interconnect modules to be really ramp up the volume and bring down the cost. But as I have surveyed, the volume of coherent DCI actually, if you compare it to PON, is less than one tenth, like only 10% or less. But yeah, we are not sure. But if my personal hope is that, especially considering the Chinese vendors are insane to push the coherent ecosystem, that might be really some hope that it will be a cost reduction to an acceptable level.
Any more questions? express mode. You mentioned that by coordinating the wireless and fixed access, you can save considerable energy, right?
Yeah.
So what is the difficulty in realizing such a scenario?
Yeah.
It's a standardization issue. It's a what is the challenge?
Yeah, actually, I think the control plane perspective, it is just fine. It's relatively easy to achieve the control of the dynamic coordination, especially if you are thinking about the single vendor proprietary solutions. But maybe if you really want to save energy from coherent optics, you have to introduce the frequency domain multiplexing because that can save energy by allocating the appropriate amount of subcarriers and mute other unused DSPs.
Okay, so physical layer technologies.
Yeah.
Okay. Thank you again. Our next speaker from the Telecom-Fiber Institute, Dr. Wang. Please.
Hello.
Oh, yeah.
Thank you very much for the presentation.
Yes.
I want. Hello.
Yeah.
Do you hear me? Okay. Yes, I wanted to understand, for example, if you have a network with a ring where different OLT are interconnected in a ring. I wanted to know if the system is dynamic in terms of QoS, quality of service. I mean, for example, if one customer is connected on one OLT and he needs more capacity and the others are not using the enough capacity, the system can calculate and know this one need more capacity and allocate the capacity to where it's needed. Thank you very much.
Okay. Can I try to understand your question? You mentioned that the customers have different requirements for bandwidth, right? Then on the OLT side, you would like something like flexible bandwidth allocation between the users. Is that the right question? Greater understanding of your question?
Yes.
Okay. Anyone? Maybe? Okay. The question is like this. Customers have different requirements.
Yes.
So maybe at this time, this customer is using this part of bandwidth, that part, a speaker. So we would like to allocate more bandwidth to that customer flexibly.
That's right.
Yeah. Are there any device or technology that can realize this?
Well, generally, we have a huge network to operate, right? So generally, the current idea is to configure very static bandwidth for each customer, so it's guaranteed bandwidth, and then we just put the best effort bandwidth for probably on top of the whole channel. But that's not so efficient because you do conjunctions and also we don't have the bandwidth reserved for the really high bandwidth customers. So the idea is that the hierarchical the DBA heavy design, we can reserve some the bandwidth just to improve the efficiency of the current DBA and to reserve and also dynamically reserve those bandwidth and to reallocate part of them or something dynamically to those services on demand. So that's the idea.
Yeah. Okay. Did that answer the question? Okay, we have a panel discussion stage, so you can ask questions at that time as well. Okay, please, Dr. Wang.
Okay, thanks.